Okay, so here we have a Megasquirt3 X Extra ECU, which as you know I've upgraded from my Megasquirt 2. The main reason for this is basically you've got a nice slot here for your data logger, so you can put in your SD card. Come on, diesel, off there, you're going to get electrocuted. So you don't have to have your laptop in the car. Very useful when you're taking logs on the track, and then you can bring them back to your PC, plug it into your SD card in the PC, and analyse your logs and make tweaks as you seem fit. The other advantage is direct USB cable, so you don't need an RS-232 converter. It's an advantage. It's not essential, but it's nice to have, I guess. And then the biggest advantage is, now if you look at the front of the ECU, I've got the Megasquirt STIM card here, which basically simulates an engine. So that's plugged into the main Megasquirt3 connector, a 37-pin connector, and you've got potentiometers here to simulate conditions in the car, like throttle position sensor, the inlet air temperature, the coolant temperature, etc. And also I've got a power pack simulating the car battery, and you've got some nice LED lights there which show you the status of things. It's a very basic sort of test really, which is advisable to do after you've built an ECU up before you plug it into the car, wire it into the car. So I've made, so here's the MS3X additional connector, so it's another 37-pin connector, and I've been soldering up this loom, as you've probably seen on my build site. Very intricate work. Done it over a couple of sessions. Your vision tends to go after a while. All these connections is what I intend to upgrade during the course of probably the next 12 months. So the main board can drive ignition and also injectors, but this gives you some more options. So you can drive the injectors from this fully sequential mode, whereas on the old board it's batch firing. So I can only batch fire because I'm a V8 and there's two injector banks, and I can only do sort of sequential, if you like. Whereas with this I can drive each injector separately. I can even trim each one if one's slightly off spec to the others. So a lot more options. One of the first things I'm going to be doing is driving my fan. My radiator fan from this. Currently it's driven on a thermostat fuse, which is typically installed in the top hose, and reading a certain temperature, 93 degrees, that will switch the fan on, and then at 89 it will switch it off. The reason why it's a different temperature, because if you imagine you switch on at 93 and off at 93, then as the temperature approaches, the fan's going to be kicking in off and on, and cause lots of spikes through your loom. So to get some control over it, you typically have a different temperature separated by 3 or 4 degrees, so hence 93 on and 89 off. So here what I've done is I've wired up a relay, because the ECU can't control the fan directly because it's too much current for it to sink through its ground. Typically sort of 200-300 milliamps is all it can handle from the various switches it controls. So that's ideal for a relay. So it basically drives the relay coil, energizes the relay coil, and that switches on a higher current, for your fan, typically 15 to 18 sort of amps, depending on obviously how big your fan is and how much current it draws. So mine's going to be drawing probably around about that sort of range. So this switches the relay on there. Now if you come over to my PC, I've got Tuner Studio already loaded up, and you see my coolant temperature is currently at 53. My fan isn't on. I've got my throttle at 64%, so I'm cruising along. Now if I go and tweak this potentiometer down here, which is the coolant temperature, and if I position you here so you can see the dial, and if you listen above my aquarium pump, hopefully you will hear the relay. As I approach the set temperature, you should hear the relay kick in. and it's not kicking in, which is why we do these sort of tests. So probably my TPS, if I turn my TPS down and then put the coolant temperature up, there you go. So I've forgotten I'd actually put in a setting in the ECU to say if I'm over a certain throttle position there's no need putting the fan on, because if I'm cruising along down the road the fan isn't going to help you cool the engine down. It might even be a hindrance to the airflow coming in. So that's the typical sort of option on OEM systems. So on a DIY system that's probably quite advanced. So if I now switch, if I do that test again, you hear it click, hopefully. Now if I slowly take the temperature down, in fact I was too quick there, if I go up, if I slowly, if I go up there, and I think you're probably going to have to just believe me that it doesn't go, let's do this very slight. So it comes on at 89, 92 rather, 93 rather even. So you can see it's still, there's a little indicator down here on the screen saying the fan's on, and you see this fan's still on at 91. Now if I tweak that down, you see, if it's quick enough there, you see that it actually went off at 89. Now if I put the temperature back up, and if you see the throttle position, at the moment it's 25%, so I've got it switched, so when it's sort of up to 70% I think, listen, the fan's gone off, yes. So here end the lesson. Bye for now.